Okay, now we're going to talk about the search functionality in the frequency scan measurement. Now, the essence of successful receiver measurements is to properly populate your signal list. And the way you populate your signal list is with the search function. You want your signal list to contain the exact signals that you wish to measure, and you want them to be at exactly the right frequencies, because the final measurement is based entirely on the signal list. Now, the N6141A lets you populate your signal list exactly the way you want to, and it does this more easily than any other analyzer. So when we're searching, we will use the scan sequence of search only. So we've got our scan already here on the display, and I'm going to do a search. So the search takes place very quickly, and you can see that I have lots of signals in my signal list. Each one of these little X's represents one signal in the signal list. If I scroll through the signal list, you can see that I've found a couple of hundred signals there. Now the reason for that is because there's a lot of this signal that's above the limits. And you can set the search criteria under mesh setup, under limits, to use the peak criteria only. So that's basically just the peak threshold and peak excursion that you will set under peak search, next peak criteria. So that's simply based on the characteristics of the signal, or the default search criteria is peak criteria and limits, and that is only going to find signals that are above the limit. In some earlier versions of the code, the default was peak criteria only. So if you get a search that looks like this, where basically every single peak in the signal is being found, go to mesh setup, and under limits, make sure that your search criteria is set to peak criteria and limits. Okay. Now, because of that last search, I've got 700 signals in my signal list, so I'm going to go ahead and clear the signal list out. The easiest way to do this is under sweep control. Simply hit clear list and start. Now, when you do that, you get this dialog telling you that it's going to delete all the data from the signal list. Now, since I'm using remote desktop, I can simply click on the OK dialog button with my mouse, but if I'm doing this from the front panel without a mouse, pressing either of the enter keys will do the same thing as clicking on OK. So now it's done the search again using the peak criteria and limits. So I'm getting fewer signals in my signal list. I'd actually like to reduce the number of signals I'm getting by even more for the sake of this demo. So what I can do is go back into the input-output menu and turn off the correction, and then go back and do a new scan, and then go back and do a search now. And again, I'm going to clear out the signal list to do this. And now I've got a smaller number of signals, which is probably better for the sake of this demo. You may also find that when you're using a margin, as you increase the margin, it will increase the number of peaks that your search will find. Let's redo that search. And now we've got 80 some odd peaks. That's good for the sake of this demo. Now, after you've done the search, you may want to look more closely at some or all of your signals to make sure that they are signals that you actually want in your list. And also, you might want to check and see if some of them are broadband signals, and you might want to adjust the frequencies for the signals to make sure that they're exactly as you want them to be. Now, with the usability features of the N6141A and the level of integration between the receiver app and the Spectrum Analyzer app, you can gain signal insight more easily than with any other analyzer. So if I press Mesh Setup, uh, the active function becomes the select signal function, and what this lets me do is I can use the knob to roll through my signal list. I'm turning the knob right now, and you can see that the green X, which shows the selected signal, is changing as I roll through the signals. And the other thing that's happening is the blue line, which represents the meter frequency, is also moving as I roll through the signals. Now this makes it very easy for me to roll to a particular signal and see exactly what the instantaneous detector values look like at that signal. And you will notice that the blue bar, the green X, and the highlighted green region within the row of the signal list, they're all showing me that I'm on signal number 7, and the meters are showing me the characteristics of the frequency at signal number 7. So the way the three regions of the display in the frequency scan app are all tied together as you move through the signals makes it very easy for you to try to figure out what's going on with your signals. Now, this is undoubtedly an FM signal, so I know that it's probably not at exactly 105 megahertz. It's probably more like 105.1 or 104.9. So I'm going to want to look more closely at this signal. Now, when you're in the signal list, remember we had the marker zoom function. With the signal list, you also have the signal zoom function. So I can zoom in on this, my selected signal, and I can see, yes, I'm not really centered on that signal. Now I'm going to adjust the frequency of the meters and try to get them better centered up on this signal. And when I do that, I want you to watch this little blue number 7 here. It's the selected signal number, and you'll see it turn white, meaning the selected signal is no longer locked to the meters. All I have to do to lock it back up is pick another signal. But the point is that the white number is an indication that the meters aren't on any particular signal. Okay, I adjust the meter frequency in the frequency menu. I'm going to turn the knob here, and you can see that I'm moving the little blue line more to the center of the signal. And sure enough, now I'm at 104.9 megahertz. And you can also see that as I do that, the meters change, which is another way that allows me to make sure I'm on the peak. It's pretty easy to peak the signal by watching the meters. Now I could actually do a meters to signal and replace this signal with the updated meter frequency. But another thing you can do with the X series is I can go to the spectrum analyzer measurement and get a look at this signal in real time. If you go to mode setup and set your global settings so that global center frequency is turned on, now if I switch modes back to the spectrum analyzer, I'll be at that same frequency. You can see that the center frequency is the same as the meter frequency was when I left the EMI receiver application. And so if I set my span to like a megahertz, now I can see the FM station in question, and it's really easy for me here in the spectrum analyzer to just center that frequency up. I can do it just by turning the knob. We can even use trace averaging to make sure we've got the signal properly centered. And it looks like we've got a good center for this signal, and as we expected, it's an FM station around 104.9 megahertz. But now we have a much better value for the frequency of this signal than we could get using a single scan in the frequency scan measurement, because anytime you're dealing with a modulated signal, it's hard to get the center of the signal with a single scan. So we've used the spectrum analyzer to get a better look at the signal, and that's something you can do in the X series. So now that we've got our updated frequency, watch what happens when I go back to the EMI receiver. Watch that frequency. It's the same as it was when I was in the Spectrum Analyzer app. And now I can, using the marker 2 function, I can replace the value of signal number 7 with this new updated value by doing a meters to signal replace function. And sure enough, there it is, 104.9 megahertz. That's the signal frequency that I really want to use when I'm making my final measurement. Okay, now I'm going to zoom out again. And that pretty much wraps up our search module part 1. So come back for a second module about searching, part 2.